Welcome everybody to the ToBeReaL webinar, the real talk navigating through technical challenges of scaling up within the bioeconomy. It's my very pleasure to moderate this session today. We have quite some interesting presentations in front of us. So we will set it up in the following way. I have excellent speakers with me today, 9 in total, and they will give their presentation first. We hope that you will enjoy them. And if you have a question, please don't hesitate to keep the question in mind and write them in the chat. So we will use the chat to follow up on your questions. And then at 11:30, we are going to open the chat Q&A session. So we will answer live all your questions that you had in the meantime. If you have any technical issues, there's also technical support present from our team. So please also don't hesitate to communicate with us through the chat or QA, so we can be of help for you. So yeah, let's get started. I'm Tanja Meyer. I'm the moderator for today. I work for the Biobased Europe Pilot Plant as a project acquisition coordinator since 8 years. And I'm in the ToBeReaL project for the scaling up and piloting of bio-based products and bio-based processes. So with me today as a first speaker, I have Laura Valentin Carrera from the P&O Spain. She will give the first presentation. Laura works for research and innovation for around 20 years, and the first 10 years of her research was about contaminants and technologies to treat polluted sites. So she's quite experienced also for the biotechnology. And since almost 11 years, she then changed to more dedication to management and development of innovation projects and follow up the business modeling, business development for bio-based innovators. So I would say, Lara, the floor is for you, and I can already see in full screen your presentation.
Right. Good morning, everyone. It's my pleasure to start this first webinar of ToBeReaL. I am Lara Valentin, the coordinator of this project, and I'm going to give you a very brief introduction of what it's about, our project, which is entitled Empowering Bioeconomy Projects by Deploying Technical, Business, Regulatory, and Social Services. So this project started in November last year. It's a coordination and support action. We are altogether 13 partners and 1 affiliated entity. You can see it in the screen who they are, and some of them are here today in this first webinar. We all cover 10 European countries, but in fact we are covering much more than that. As said, P&O Innovation, the branch in Spain, is the coordinator of the project. Is me and another colleague of P&O Spain, Maria Jimenez. And then you have here our website and the LinkedIn thing. So what is our main goal? We can summarize just in few lines. The main goal of ToBeReaL is to catalyze public, private, and both public and private bioeconomy projects at different stages of maturity, but with the unique purpose of leading you to a higher readiness level, so that you can even become a flagship. Your own project can become a flagship project across Europe. So I say the unique value of ToBeReaL, there are many things that are going on in the project, but I'm going to summarize the key values of or the unique services that we are going we have already started to offer you. So first of all, we start everything, and we are still going on to identify key barriers, but also needs that are limiting the scalability of bioeconomy projects. This is the first step in our project that we have been internally working a lot to create a really nice 5 open reports that are going to be public soon for all of you to read in the different verticals of business, of technology, of social innovation, of regulatory and legislation. So they are going to be there ready for the community. Then we have been also very busy for the last months since we kick off the project to define what is the best package of assistance for you, for helping you, and is done, and you can see it in our website. So we have our cornerstone of the project is the portfolio of services in 4 verticals that I'm going to explain you more. This is ready, but further than that, we want to collaborate, we want to foster collaboration among all the stakeholders in bioeconomy. How? Like now, like today, preparing webinars. This is the first one. We are going to have 6 more. We have workshops. We made one the first one last month in Slovakia, and there are 4 more to come in different countries. These are in-person, face-to-face workshops. And then we have the BioPitch forums events that there are going to be 3. They are much larger, embedded in key European bioeconomy events, thanks of the participation of key partners in our project. And then we have a long-term assistance strategy for you, because this is a quite long project, and we want to ensure that not only by giving you this assistance, giving you access to our reports and these events, this is okay, but we wanted to give you more long-term assistance until the project is finished, which is going to be in 4.5 years. So as said, the BioPitch Forum, we believe it's a key event in ToBeReaL, that selected projects are invited to foster matchmaking and collaboration, to generate ideas, to pitch your projects, because in these forums there will be different kind of stakeholders, from feedstock providers, technology providers, but also investors. And as I say, they are going to be included in big already existing projects, like, for example, the one that BBEPP organize every year in Belgium. So the first one, you will have to wait a while, because we need to meet people, to meet projects. So it's going to be in September 26, and this time is AINIA, our partner AINIA, who will organize it within their national program related to bioeconomy. So what else? The part which we are very proud, that we offer these services to bioeconomy actors to boost your projects to higher readiness level. So we have 4 verticals: the technical assistance, the business and financial assistance, regulatory and policy assistance, and the social innovation assistance. So through a system based on ToBeCoins, which are the value that we are giving to our services, you can pick up the best services that match your needs, always thinking that you have only 60 coins, ToBeCoins, to be used. Each of these specific services has a value, accounts for a value. You can see it in the website. So what we have from the technical, we have, for example, I'm not going to read them all, but for example, to give you an idea, we can give you service about bio-based supply chain assessment and optimization, but also basic bioeconomy, techno-economic assessment. From the business point of view, we can give you assistance on how to go to market your outcomes and this exploitation strategy that you need to follow in order for you to grow. Regulatory, we have both policies and strategies, but we also have European and national regulatory environment assistant. And we have the whole package of social innovation. It's very important you also take into account the social readiness level of your project in order to be closer to the market. So we can have assessment of the social impact, also stakeholder mapping through workshops, etc. So please go to our website, look at the services, and apply. But how to apply? if you go to our website, there is this apply now, and then there will be then you will see these packages of the services very well explained. You have even more details of each one and the value. These 60, you have in total 60 coins, and each one has a little, you have to make your own combination. Make sure that you fulfill with the definition of bioeconomy project and flagship project. It's very important for us to service projects that they really are going to have a future impact, and choose your own combination, and then just make the application and we will receive the application. You have, this is something that you will see. This is the application to ToBeReaL services. There is first a questionnaire online, but for you to help you writing at home, offline, this is the application package. You have the guidelines for you to know what we are going to request. There are this initial questionnaire with some preliminary questions and the readiness level forms, because we need to assist to evaluate in which level you are now, so that we are really sure that with our help you can increase your readiness level. And of course, ToBeReaL is transparent, and we want that you read what is the evaluation criteria and the scoring system that us as evaluators as well, we are all doing that evaluation, we are going to fulfill. If you have any doubts, here you have our email. And that's all. I hope you enjoy the webinar, and I give the floor back to Tania. And please, if you have any doubts, we have the Q&A session, and that's all for me. Enjoy the webinar.
Thank you, Lara. That was great. Yes, for the people and participants joining the last couple of minutes, we will take first all the presentations, and you have the option, if you have a question, like we received a couple of questions already now, to write them in the chat or the Q&A session, and then we take up the question at 11:30, around 11:30. Yes, so if you cannot bear with us the whole time, you can also leave your email address or something, or contact us later so we can get back to you offline to answer your question that you might have. Okay, great. Let's move over to the next speaker. I would like to introduce you to Muriel de Wilde, working at BioBase Europe pilot plant as the business development manager since almost 15 years already. So basically almost since BioBase started. And she's going to present us today the challenges and solutions when scaling up, the use case of microbial protein production processes. So Muriel, thanks for having you here. And yeah, I can see your presentation, not yet in full screen mode, but it's coming. Yeah, now
Thanks,
it's all in
Tanya,
full
for the nice
mode.
introduction. Do you see the right mode now?
I see the right mode, yes, thanks.
Okay, so welcome to Ghent, to the BioBase Europe pilot plant. Let's see if I can switch the slides. Yeah, and I'll talk to you about challenges and solutions in scaling up microbial protein production. What we basically do at BioBase Europe pilot plant is turning grams into tons. Who are we as a company? We're an open access pilot facility. We are fully independent. We don't have any industrial shareholders. We're a not-for-profit company, which means any profit we make is reinvested in new equipment in the plant. The reason for this structure is because we received most of the 80 million euro we invested in equipment in this plant through public grants. Since our founding in 2008, we grew to 160 employees currently, and we've installed over 57 fermenters. In the course of the years, we implemented quality management systems certified with ISO 9001 and the food grade FSSC 22000. We also have an FDA approval, and for our French customers, certified by the French government for the Crédit Impôt Recherche. This means we make technical grade products as well as food grade products. We don't make pharmaceutical grade products. We're a mission-driven company, and our mission is to enable the transition to a sustainable bio-based economy. And we do that through providing 3 types of services. That's process development, scale-up, and custom manufacturing. And again, all the products we make are bio-based. Our plant is a one-stop shop, which means that underneath one roof, we bring in the biomass, we convert it to a final, refined, bulk business-to-business product that we deliver to our partners and customers. And the biomass types we bring in are first-generation sugars like glucose, sucrose, that we just buy on the market, or second-generation sugars from, for example, lignocellulosic feedstocks that, of course, require some pre-treatment before being fed as fermentable sugars to a fermenter, for example. We can also valorize side streams from food industry or from agriculture. And since relatively recently, we can also convert organic waste in a separate dedicated part of the plant in which we don't make food products. A special feedstock for our piloting is also the C1 waste gases, so CO2 or CO from biogenic sources, for example, ethanol fermentations, from industrial waste gases, for example, steel mill industry, or from syngas, which is basically produced via gasification of solid waste. The final products we make are quite diverse. We make food products, cosmetics, chemicals, materials, and preclinical therapeutics. Because we are a state-of-the-art pilot facility for the entire bioeconomy. So to mention the products in a bit more detail, those are microbial proteins or microbial fats, industrial enzymes, specialty sugars, and nutraceuticals, like soluble fibers, for example, natural colorants, flavors and fragrances, cosmetics such as biosurfactants, medical biotech products, fine chemicals, chemical building blocks, materials, bioplastics, fuels, so the more technical products. And we work for the agricultural technology when we produce biostimulants and pest control agents. How do we help our customers and partners? For that, I have to explain this graph. And on the horizontal axis, you see the path from lab to industrial reality and the different stages of development of a new technology. That typically starts with basic research. In the middle, there's a product development and piloting. And in the final stage, the technology reaches commercialization. During these stages of development, the technological risk of the technology goes down, but the capital requirements go up. So before you can really translate a lab-based protocol to an industrial process, you have to cross this very difficult stage, which is called the valley of death. You have to invest a lot in industrial equipment, but you don't have any revenues yet from products because your commercial plant doesn't exist yet. So this valley of death is made smaller by our activities because we already have the equipment, we have the expertise, we can just help you cross this valley of death. So to come back to the different services we provide, first, the technology needs to be developed. The basic idea has to be turned into a scalable, sustainable, and cost-efficient process. And we do this tech transfer and proof of concept as a first stage during scale-up. The second phase is optimization, validation in industrial equipment, and initial sample production. And the later stage, typically done at 50 cube scale, is demonstration, production of market introduction samples. And sometimes you also have to downscale because we encourage our customers and partners to begin with the end in mind and to first have an idea in what kind of industrial plant they would want to produce their final product, and to downscale during the piloting trials that industrial setting. So process development is done in our plant at bench scale or 100-liter scale. We invested a lot in small-scale equipment. The scale-up is done at 100 liters, 1,000 or 10,000-liter scale, in which we can already demonstrate the technology in scalable equipment and generate quite some process balances and data that is also all transferred to our customers. And we can start their first of a series production in our largest equipment, which is approximately 50,000-liter scale. There are basically two ways in which we collaborate with customers and partners, and that's on the one hand within bilateral projects on a fee-for-service basis. These projects are fully confidential. The customer brings their basic protocol, their basic idea, their modified microbial strain, and that IP remains with the customer when we bring their technology to scale. On the other hand, we also collaborate and partner up in publicly funded consortia, typically funded by Horizon Europe, of course, but also by the Flemish VITO. Within these projects, we also build up our own technologies and experience. We build value chains, and we can present the results of these projects, so that allows us to communicate about our activities. We've served over 400 companies within bilateral projects, of which the majority from Europe, but also quite apart from the US. Within public projects, we've done 100 of these, and 37 are currently ongoing. So which technologies do we have underneath this roof of our pilot facility in Ghent? We have 4 piloting spaces, piloting halls, which we flexibly dedicate to different activities like biomass pretreatment, biocatalysis, gas fermentation and fermentation, green chemistry, downstream purification. In the central building, we have our lab spaces. We have a technical services department for maintenance and engineering. We have warehouses and logistics spaces, and an office building, of course, with customer hubs in which customers stay while we perform trials for them. And they also frequently enter the plant to see the progress of the pilot trials. And here comes driving in our bio-based mobile pilot plant that holds our 150-liter gas fermenter. To go inside the plant and see some of our equipment, on this slide for biomass pretreatment, we do milling, pulping, thermal treatments, enzymatic conversions, and solid liquid separations. In the field of biocatalysis, we have all kinds of reactors for aqueous and even solvent-based or 3-phase reactions. We can also immobilize enzymes for continuous biocatalytic conversions. And also there we have auxiliary equipment to produce and purify enzymes and to perform the downstream purification of biocatalytically produced products. This is the array of bioreactors we have at the BioBase Europe pilot plant. It's the heart of our plant. We run batch, fed batch, and more continuous fermentations. We grow all kinds of hosts, bacteria, yeast, and fungal strains. We have fermenters ranging from the lab in glass bioreactors all the way to 75,000-liter fermenters with many scales in between to perfectly guide the scale up. Then the gas fermentation I already briefly mentioned, in which we convert CO, CO2 to chemicals via gas fermentation. And at the bottom picture you see our mobile gas fermentation plant that holds a 150-liter gas fermenter and an electrolyzer to generate the hydrogen. In our green chemistry zone, we can work with organic solvents for example, solvent extraction of metabolites or chemical reactions like esterifications. Also for biomass pretreatments, because these chemical reactors can also be pressurized and they're glass lined for corrosive conditions. Also there we have solid liquid or other purification equipment that is compatible with the explosion-proof conditions for organic solvents. Furthermore, in downstream purification, we have cell lysis equipment, high-speed separators to separate bacterial cells, filtration equipment to purify or concentrate sugars or proteins. We do ion exchange to remove salts, chromatography or active carbon treatment. We evaporate water in our different evaporators. We can crystallize products like organic acids or sugars, and we can dry them. Now, why is it so important to do piloting? You have to de-risk your process and be sure to fail small. Select the right unit operations, so by the time you will build your own plant, you know which equipment to install. You have to define the process and then, of course, prove that it works, so validate it and build the process flow diagram that you will need to build your industrial facility. You have to generate mass balance data, composition of the side streams, and the final product quality, of course. You have to test product applications to build customer relationships and to build up market demand. You have to gain investor confidence by showing that you can reach a certain cost of goods, that there is customer demand. And you have to prepare for construction of your plant or to prepare the onboarding into a CMO, a contract manufacturing organization. And gain product experience and train your operations team that you will need to hire as well. There are, of course, a lot of challenges when you start piloting, and that's actually also the purpose of it. You have to test the robustness, you have to test if there are byproducts being formed, whether your process is repeatable, what the yield is, the productivity, if the oxygen transfer is sufficient, if foaming occurs or lysis occurs, or if you need to feed special feed streams that require specific sterilization procedures. You have to make sure you don't get contamination, that your strain resists the pressure that you need to apply to transfer the oxygen, that your special feedstock doesn't have inhibitors. And also in the DSP, you can run into quite some issues. In a filtration, you can have some fines that don't get filtered. You can lose some of your yield in separation steps. You can have an emulsification if you do a solvent extraction. You can have product degradation or fouling of your equipment. You can have an off taste or black particles in your final product. You have to make sure you can run 24/7 to run through the process fast enough not to get deterioration. So back to proteins now. What is actually microbial protein and what is its landscape? Because there are many types. We have, for example, single-cell protein, which is produced through a biomass fermentation of fungal strains or yeast or bacteria that have in itself a very high protein concentration. We can also make dairy, egg, or meat protein replacers via precision fermentation, so typically genetically modified organisms that express these biosimilar proteins like casein, beta-lactoglobulin, lactoferrin, ovalbumin. And this is actually a graph that shows a lot of these food-grade biosimilar proteins. We can also make industrial enzymes, natural colorants, sweet proteins that are, for example, 1,000 times sweeter than sugars, antibodies to be used in agricultural technology or in human drug use, collagen for cosmetics applications, gelatin, keratin, silk proteins, also for cosmetics or materials applications. So which companies did we already bring from lab to fab within this space? Enough, that makes a fungal meat replacement. Arbiom, French company, that also makes a single-cell protein for food and feed applications. OnigoBio, that makes ovalbumin, an egg white replacer. Those Vegan Cowboys make casein for cheese. Vivici, beta-lactoglobulin for sports drinks. And Biotalis, antibodies for fungicides in production of berries. So we scaled up the process of these companies. So what are some specific challenges when you start producing proteins? As you can see from the molecule ovalbumin here above, you can see that's a very complex structure. And that's important for the final applications like foaming or stretchiness, or but the structure is very difficult to analyze. It's also impacted by how you treat the protein. You risk to irreversibly denature the protein, and then it doesn't have these nice applications anymore and properties anymore. You can have protease activity in your process that breaks down your protein of interest. You can have microbial contamination in the downstream process. The nice functional properties can also cause issues during processing, such as foaming, emulsification, stickiness onto your equipment. Maillard reaction or enzymatic breakdown can cause off flavors or colors. Proteins can be allergenic, so you have to foresee safety measures. And they're very complex molecules, so also difficult to predict how they will scale up and behave in a plant. So how do we tackle these challenges in a structured way? Our equipment is state-of-the-art, and we have sound sanitation and maintenance procedures. We have all analytics to quantify, measure, and control the process 24/7. We have the technological know-how to run this equipment. We do a very structured preparations of the trials. We set clear objectives. We do a risk assessment. We have plans and backup plans because things typically turn out different than you had anticipated. During fermentation, we have to make sure we have an affordable feedstock, that we have a robust seed or inoculum, that we decide whether we run a continuous or a fed batch process, and how we then define the feed strategy, the aeration strategy, foam control, and sterility. The downstream process, so the purification process, needs to be simple and robust to be affordable and workable. We need short processing times, preferably with continuous processing. If any unexpected events occur, which is typically the case during piloting, you have to do a root cause analysis to make sure you learn from every event. And you typically do that all together, all heads around the table. And you have to generate a lot of data because this is the moment where you have very close follow-up and a lot of experiences and testing of boundaries of your system. And last but not least, this is all teamwork. It's a lot of fun to do it, but you really require a lot of expertise and different backgrounds. So this is our team of 160 people that is very enthusiastic in doing this together with you. Thanks for your attention.
Thank you, Maria. I think that was super insightful. Really nice. Okay, as said, we take up questions at the end. So thanks, Maria, again. Then we can continue. And I get the help of Teodoli. We continue with a presentation from Fernanda Timoteo, who's a chemical engineer. Also a very pleasure to have her contribution, because she's one of my colleagues. She's experienced in biotechnology, from gaining a lot of experience in biochemical conversion of biomass feedstocks, fermentation, and also DSP. And now she's mostly working at the biorefinery for techno-economic and environmental analysis, and that's also the topic she's going to talk about.
Yeah, so hello everyone, my name is Fernanda Chimoto. I'm a PhD candidate at Biobase Europe Pilot Plant, and about techno-economic analysis, or for short, TEA. So this is a method used for evaluating the technical feasibility and the economic viability of a technology, a process, or a project. And this is important for many different reasons and can be used for different outcomes. So this allows you to assess the cost, the performance, and the profitability of your process or your new technology, and helps you then identify bottlenecks in your process to set research targets where you should improve, and to also evaluate the impact of changes or uncertainties in your project in technical aspects or market aspects, such as the product price or different raw material prices. And this can also be a basis for an environmental assessment. The outputs that you generate from a TEA can support your environmental assessment in a later step. And overall, the TEA will support decision-making to better assess the risks related to your project or your technology, and to make an informed decision on investment and cost-wise. So just a general workflow overview of how a TEA is performed. We initiate with a process design where we define all the unit operations, all the equipment that is necessary for each step of your process, which then will lead us to a process modeling, where we do a process simulation using a commercial process simulator software, such as SuperPro Designer. And there we can include all the unit operations and the streams in between them. And this generates then the mass and energy balances of your whole plant in an industrial scale, which will then allow us to calculate or estimate the capital costs of each piece of equipment and then your overall plant, and all the operational costs related to the raw materials, the utilities, consumables, and labor that is needed to operate this process. This will then lead us to the financial analysis, where we have a cash flow of all the costs and revenues throughout project years that allow us to calculate financial metrics, such as the internal rate of return or the payback period, for instance. And having these models, this allows us to perform sensitivity or uncertainty analysis, where we can vary different parameters and have a range of what will be your final product cost, for instance, or your internal rate of return if these parameters change. And these can be technical parameters, such as a yield or conversion in a certain step, or market parameters such as the feedstock price, for instance. So this gives you a very good idea of the robustness or the sensitivity of your economic performance regarding different parameters. So Biobase has worked in different projects involving TEA work. And here I'm bringing two examples of scientific publications in which Biobase was involved. One of them for producing single-cell protein from industrial off-gas, and another one for producing jet fuel, where one of the pathways was also involving fermentation. And I'm going to focus a bit more on the first one, just to give you a little bit of an example of how this can help us develop, further develop research in a certain area with TEA. So in this publication, we were talking about valorizing industrial off-gas through a dual-state fermentation or coupled fermentation via acetate, where in the first step we convert the gas to acetate, and then in the second fermentation stage we convert acetates to microbial protein. And the overall simulation of this process and the TEA helped us, for instance, in setting the research targets of acetate productivity and concentration that we need to reach in order to achieve a competing production cost for our microbial protein. So if, for instance, you say you need to get the price down to 2.5 euros per kilogram, you know which acetate productivity and concentration you need to target for that. Another example of what you can get from the TA in the same example is the effect of production scale. So for sure, when you're increasing production scale, you increase capital investment. Here are two scenarios. So in the lines here, you see the investment increases, but your unit production cost, or the cost for each kilogram of protein that you produce, decreases as your production scale increases. So, and then you can find what is the optimal production scale that you should target based on market constraints as well, and your process. So these are two examples, and in Biobase we can support you throughout these steps. So basically put into very defined steps. We first have the process definition, then we analyze the general mass and energy balances based on your input. We do an initial feasibility and optimization, and then we move forward to the process simulation, where we then will have the final mass and energy balances all simulated, which leads us to the cost estimation of both CapEx and OpEx, the economic analysis, and then we can perform a benchmarking with, for instance, a technology that is already commercial, that is already available. How does your product, your technology compare in relation to this benchmark? And then finally, a little bit more outside the scope of the TEA and transitioning into the engineering services we can already provide. This is linked then to the scale-up support that we can provide, the feasibility studies and technical due diligence. So Janko will talk a little bit more about those now. Thank you.
So that was the presentation on the TA, because it's one of the services that we as Biobase Europe pilot partner are offering in the ToBeReaL project. In the course of this webinar, we hear also from other partners and their service that they're going to offer. Now with Janko Avram, a project manager at Biobase Europe pilot plant, we do the same exercise. He has a PhD in electrical engineering from the Ghent University in Belgium, and is also involved in the engineering part, for example, from the 75 cube fermenter, and the topics of automation and also cybersecurity. So yeah, let's see what we can offer from the engineering services.
Hello, my name is Janko, and I will introduce to the engineering services that Biobase Europe pilot plant has. So I said we are part of Biobase Europe pilot plant, and here at Biobase, almost from the start of our company, we decided to design and build our own piloting installations, because we saw that what we needed was not really available in the market, and that the design knowledge of designing these sterile fermentation installations was not completely there. So we built our own installations. And I think it's also important to mention that we also operate these. So you're constantly able to learn from your operational colleagues what works, what doesn't work, what can be done better in a future iteration, and so on. And also important to mention is that being part of the Biobase Europe pilot plant, we can also lean back on all this process knowledge that we have. So we really understand fermentation processes, know how they work, and that means that when designing installations, we can also perfect fine-tune them to your process so that it's really tailor-made and that you only build and pay what you need. So we know where to cut corners and where you shouldn't cut corners. What is our mission? So we had all this experience here designing our own installations. And we said, okay, why not leverage this experience to also help our customers when building their own demonstration and production plant after they had a successful piloting run. So really to help these companies grow further up to a point where they have a production plant and they can make profit off of their product. Another aspect of our mission is that we also help companies that already have a production plant and experience some difficulties concerning cleanability, sterility, or they want to improve the production output. And also here we can assist these companies. Now, I have here the typical phasing of an engineering project. We start with the feasibility study, then we go to basic and detailed engineering, implementation, and delivery. And at BioBase, so with engineering services, we can offer support during the whole project, so both feasibility study, commissioning, and anything in between. But here, it's important to mention we try to focus on the biotech part. So really on the sterile design, on the fermentation, on the DSP equipment. We're not a typical EPC company where you say, okay, come to us and we'll build you the whole package. We focus and we do what we are strong at. And then we recommend our customers to work with the local partner for civil, for piping, for electrical wiring, and so on. I don't have time during this webinar to go through the whole project, but I wanted to focus on a few things. And first is during the feasibility study, the importance of having a good basis of design. And this means that you start with the correct assumptions, and assumptions like production scale, like fermentation strategy. How do I do the DSP? Do I do it continuously? Do I do it batch-wise? How large are the batches? What are the regulatory requirements? What are the quality requirements? Things like that. And this is important because you will carry these decisions along with you during the whole engineering project. And it is here that you can have a large impact on your CapEx, on your cost structure. By designing a more efficient installation that is smaller, you can save a lot of money while still meeting your production target. So it's important to get this right before doing the rest of the project. And this is also where we have a lot of experience here at BioBase, because we have all this process knowledge, because we have knowledge of all kinds of DSP strategies, of fermentation strategies, what are the benefits of those. So here we can really help you achieve an optimal plant design before you do the rest of the engineering. Another thing I wanted to mention during the basis engineering is the importance of piloting, and piloting to a scale that is as close as possible to the target production scale. And that is because you can predict some things using simulations, using results from small scale, but it's living organisms that you're dealing with. So it's difficult to completely predict how they will behave on a certain scale, how the OTR will be exactly. And this can save you money in the long run, because if you remove uncertainties with piloting, you can lower your design margins. And this way, piloting pays itself back, or even more than that, because you design again a plant that is more tailor-suited for your project, and you don't design too much overhead, too much design margins, which in the end might prove not to be needed. A last thing here I want to touch about is the importance of proper equipment selection, and that is because half sterile does not exist. Either you have a sterile process or you have a non-sterile process, and it can come to bite you in the end if you say, okay, but sterility is not really that important. If it proves to be a problem, it is very difficult to make a non-sterile installation sterile. And furthermore, if you know, again, where to cut corners, a sterile installation does not need to be much more expensive than a non-sterile installation. So also here we we can help you achieve CapEx-friendly sterile installation so that you can rest assured that your production will go smoothly. So this was it. I'm afraid my time is up. But if you want more information on where we can assist, not only during feasibility and basic engineering, but also during the other phases of the project, please reach out to Tanya or to business development. Thank you very much.
Okay, so now we heard about this very important services also that are often a little bit neglected to the side when bio-innovators are basically focused more on implementation and DSP, but it's a really consideration for long term. You can also raise questions to these two presentations, and we take them up later in the Q&A session. Okay, let's go a presentation further. With us today is also Ruth Manzanares-Rubio. She's the head of open innovation at AINIA and also the Startback manager. She works there already for 2 years, and before she was also working as the executive manager at the Institute of Molecular Science. So Ruth, it's a pleasure to have you here as well today. And yeah, if you would be so kind to share your presentation.
Yeah, sure. Thank you for the great presentation, Tanya. So just let me share my screen. I hope you can see. Oh, yes, just let me adapt text. I hope you can see it properly now.
It's in full screen mode. Yeah, you're ready to go.
Okay, so perfect. So it's a great pleasure for me just to have the opportunity to introduce you AINIA and what we can just do for you within this project. So just a brief presentation, of course. We are based in Spain. We are a non-profit private technology center with more than 35 years, I think 38, of experience in R&D and I. We are focused in agri-food and bioeconomy sectors. We are actually the national reference center in bioeconomy in Spain. And I always say we are more than 300 people. And I always say that 70% is our kind of key number, as 70% of our, we are actually an association. We have more than 800 companies associated to our center. And I was talking about 70% because the 70% of the companies associated to AINIA are SMEs, and the 70% of our income comes from the innovation services we provide to our customers, and almost 70% too of our personnel are PhD and graduates. Just talking in different technologies. We are talking about them now. And what we do, we are innovation center, so we develop any kind of activities related to sustainable innovation. Of course, we develop R&D and I projects and technological assistance and analytical services and training and consultancy, law consultancy, consumer studies, industrial services for sure. And as I was saying before, most of our income comes from the technological services, innovation services we provide to our customers. We have more than almost 2,000 customers, different customers from all around the world. And for doing all of these things, we count of more than, I think there are not 14 anymore. I think that we are 16,000 square meters dedicated to innovative technologies. We have 21 pilot plants, 11 labs, and a huge industrial plant for supercritical CO2 extraction. The name is ALPEX. So I'm just trying to give you a brief overview of the research and innovation lines we have, but I will always focus in the lines that are related to ToBeReaL project. Of course, I'm open to talk about any of the things you're gonna see here in my slides, but just please, for the moment, just you have only to pay attention to the highlights I'm gonna give you, because they are the lines that we are working related to ToBeReaL. So of course, we are focused in 5 main challenges in future food, of course, in green transition and food security and safety, health and well-being, and digital transformation. So just talking about future foods, as I was saying before, you're going to see a lot of things here. But just let me highlight that, just for instance, we are working in new protein sources in single cell proteins, alternative biomass from plants, insects, and microalgae and fungal, etc. We are working, of course, in plant-based and hybrid products, maybe more in hybrid at this moment because it seems that the market is going that way. We are, of course, working in cell agriculture for cultivating meat and ingredients, in clean technologies. We are very focused on sustainable innovation. So we are working with green solvents or supercritical CO2 extraction, as I was saying before. We work, of course, in upcycling of byproducts, creating new ingredients of higher value products. And of course, we work in life cycle analysis and environment footprint calculation. So this is just regarding future food, just for food quality and security, which is one of our main areas too. So we're working in, just for instance, these new methods of stabilization and preservation, and we are developing new alternative antimicrobials, just for instance, based on natural extracts. And of course, with everything related to the launching of new processes or products to the market, just for instance, chemical and biological analysis or migration of materials in contact with food in case, for instance, of new packaging. We are working in packaging too. And the main area related to this project, I think, which is green transition, we're working in a lot of things in this area. We're working in upcycling and waste valorization within biorefinery concepts. As I was saying before, we are working in packaging, not only in the recyclability and reuse, but in the development in new biomaterials and also in the eco-design of the packaging. We are very specialized in water. So we work in reuse and purification and treatment of wastewater and processed water, and not only the treatment of the water, but the revalorization of the waste we can find in the water streams. We are working, just developing new biotechnological active ingredients for biostimulation and biocontrol. Of course, we are working in biofertilizers and biopesticides. New processes for energy, yes, we are very focused in bioenergy and biofuel production, just biogas, biomethane, biohydrogen, and process sustainability. Of course, we help our customers to improve the sustainability of their processes. And just talking about the digital transformation, because I think I'm not talking about the health and well-being because it's out of the scope of this project. In digital transformation, we have everything related to, of course, the process control, the sensor with sensors and machine learning and everything. We are working in prediction and risk assessment, in development of new products, in robotics and automation, and of course, in everything related to agriculture 5.0. And I think we are almost at 5.0 at this moment, but okay, 5.0. And of course, we, as I was saying before, we operate worldwide. We're based in Spain, but we have a great network of experts and a lot of partnerships with major public and private entities. We just go through innovation with them. This is just a brief explanation of the kind of projects we are developing internationally, but I think that maybe the most important one, this one, is the kind of European projects we are working in. We are working in this moment, we have 20 running projects from 7 different calls. And we have partnerships with people around the world, not only in this kind of European projects. This is a brief, there is draft of the European projects we have been working with, and we are actually working some of them with some partners, and all of them are related to bioeconomy. And just, I think super on time, so I think that I have time enough. Okay, for explaining to you what we can provide you within ToBeReaL project. When we had to design the services we wanted to provide, we decided to go for the services where our broad knowledge of different technologies in bioeconomy, and also our grid network, specialized the associated we have and the international partners, where these two things could really provide a high value to the participants of the project. So we decided to go for these kind of services. Just as, for instance, we are providing, just talking about technical assistance, We are providing the techno-economic assessment. We offer basic techno-economic assessment using process analysis, as it was described before me, simulations, feasibility checks, and we of course include all the cost estimates, the CAPEX and OPEX, the key economic metrics, the sensitivity analysis, and all the scale-out support. And everything is done in a tailor-made way, just for trying to help you as much as we can in this service. We are working too in the technology intelligence. We are providing a deep dive into emerging bioeconomy technologies through tech scouting, of course, patent analysis, mapping key players, which is quite important. And we hope just to be able to help you to make smart decisions. Okay, just by showing you where each tech stands and what the market trends are and how it fits in your region. Okay, we are trying to focus in the region we want to, you want to work. I think that it's super important, and of course, with an eye on sustainability and investment potential, because then from this, we're moving to everything related to the business model and business plan creation and improvement. We can help the bioeconomy projects. We are actually doing it as a part of our daily work here. So we have bioeconomy projects shape their business plans and models, and we try to highlight their economic and social value. Of course, the technology value too, but we try to highlight too their economic and social value. And we are helping the companies to build smart strategies, and we are using tools like business canvas, of course, the SWOT analysis, the market research, the competitor mapping, as I was saying before, and also offering training and everything and information, everything you may need related to this item. And of course, we are working with you in the identification of public funding opportunities and the application strategy design, which is not as simple as it may seem. So we are trying to help you to identify the most suitable public funding opportunities in an European, national, and also regional level, and just trying to help you even for effective proposal writing. Okay, just for preparing all the proposals you want to present. And we were talking about public. We are also helping you for trying to find private funding opportunities. They're using our network. We are trying to help you just to connect your projects with private funds and investors. So we want to prepare you and your application just to be the most suitable it can be to the different private investors that we can find all around Europe. And of course, we want to help you to improve your speech and just to try to do an impactful pitch, which is not, as I was saying before, as it may seem. So I think that's all from my part. I think I'm on time. Of course, as I was saying before, we are fully open to talk to you and collaborate to you. Of course, we are really, I really like this slide, but it's true. I can tell you from the center, I'm alone in this room, so I can just talk free. And really, we are an organization with a purpose. We are really helping people just through innovation. And of course, we are open to help you in anything you might need.
Thank you, Ruth. That was super catchy. Thanks a lot.
Yeah. I'm stopping. I don't know why. I'm sorry, I lost.
It's fine. I can then introduce the next speaker, perfect. Which is Ruben Guison. He's a MOF manager at VITO. He works as a lead researcher and consultant in the field of supply chain optimization, bio-based economy, sustainable transition, and innovative value chains. So Ruben, we can already see your presentation in full screen, so everything is fine and you're good to go.
Okay, thank you for the introduction. Good morning, everybody. I will give my talk on behalf of VITO. VITO is a Flemish research technical institute with about 1,000 people active, doing research on a lot of topics. So for the sake of this presentation, I will focus it on the activities that we have in ToBeReaL. As a technical assistance package, we are active in the project on supply chain design and logistics in the bio-based economy. And maybe to frame this a bit, like why this is important is that what is obviously no secret to you is that the bio-based resources don't magically end up at the gate of a biorefinery, nor are they further distributed towards, let's say, wholesalers, etc. And this comes at a cost which is mainly or largely overlooked, but which is very important, specifically because, as we also know, bio-based products suffer a bit on being economically competitive. So when we look at logistics, and it's just high frame numbers, logistics means, you know, the transportation actions, moving things from and front, but also the activities in between, like storing them, handling them, pre-processing them. Well, this represents a significant share in the final overall cost of making bio-based products. And depending on the typology, like having like raw biomass fuels, this even adds up to the range of 20 to 40%. When you go up in higher added value products, this has a tendency to decline a bit, but still it's double-digit numbers, and it's an important cost matrix that needs to be taken into account, and that's where we are active in. So why is it specifically important in bio-based economy and bio-based supply chains? Well, these products have the tendency to be lower in value, often is worked with rest products, byproducts, also have a low mass density, also low energy density, meaning you're moving around more volume or a lot of volume, and also often a lot of water. These resources are often geographically very dispersed, which means you need to drive around a lot to gather mass, to gather this volume. Additionally, there is a lot of additional handling. It's biomass, it deteriorates, it degrades. So you need some activities there, which other products mostly don't need, like drying, compacting, having a lot of loading and unloading activities. As well, the high variability in quality of products, creating problems towards grading and quality assessment. Also, seasonality, specifically in our regions, is of importance, which creates peaks in production of the biomass, while this needs to be stored in between to allow processors to have a whole year processing activity. And all this leads us to the conclusion that a well thought out logistics strategy, a mobilization strategy for the biomass, and a good design of the supply chain where your activity is taking place is key for the long-term feasibility of the bio-based business cases as a whole. And this we framed in a 2-minute short animation. It's quite high level, but I will launch it on you because it grasps perfectly the let's say the intention that we have with our service that we provide here. I will launch it now.
Having trouble coming up with the best design for your supply chain? Move can help. Move is a service that improves the efficiency of your supply chain and reduces its cost. Let's see how. Goods progress through the supply chain from raw materials to pre-processing intermediates, via storage, and final processing to products ready for shipping. A poorly thought out supply chain network leads to inefficiencies and lost profits. The costs of inefficient design are often hidden, but they have a long-term impact on the overall supply chain performance. Finding the best design is challenging. Countless variations and options are possible, and each option is influenced by a complex set of parameters, such as quantity, quality, location, planning, and costs. To help create the most efficient supply chain, we have developed Move, our network design optimization service. Move takes account of all relevant parameters for each network option and finds the best configuration while meeting your specific needs and objectives. The resulting cost efficiency improves the performance of your chain. You can use Move to address supply chain questions such as, are our storage facilities located in the best place? How big should they be? Should we open new facilities and/or close old ones? Could operations be merged into a single site? How do we combine different transport modes most efficiently. The results of the move analysis are clearly presented in an online dashboard. One click lets you compare the different scenarios side by side, highlighting the efficiency improvements and cost savings. Our team of experts will guide you through the complete process and provide support and advice when and where it's needed. So, whether you're planning to design your supply chain from scratch, looking to improve your existing supply chain, or transforming it into a new one, Move supplies the decision support you need.
So that was in a nutshell the service we also provide within ToBeReaL, and I want to dive a bit deeper into the activities that we would engage into with you if you would apply for our service. First, we address, let's say, the supply chain at hand, being it from field to shell, kind of speak, and all the activities in between. It can be set in collaboration with the client's needs. We include all forward as well as reverse logistics. Obviously, within the geographic context, that will become clear by some examples I have later on. We can engage also in smart first mile pickup rounds, collecting resources at field or at installation, and also smart, let's say, last mile drop-off strategies for products. Also, we're actively working on embedding circularity into the system, allowing it to go from linear to circular. So that's on framing the supply chain and the activities at hand. We take into account key parameters like locations, or to reference, it can be starting from the as-is situation, but most often we also look at to-be scenarios where we look at different locations where new operation could take place. So location of activities is obviously an important parameter in the supply chain logistics design. The timing and the planning, taking into account seasonality, how long storage can take place, when products need to be at which location. Illustration of quality. Obviously, you have different grades, and it can be that depending on the grade, products need to go to different downstream processing installations. Volume and mass, throughput capacity needs to be fulfilled throughout the value chain so that no bottlenecks occur, nor in the processing of the products, nor in the storage or in the transport of the products. And finally, and not least, because this happens a lot, specific conditions that clients have, where they say, you know, we want to green our fleet, we want to have 20% of our fleet going electric in 5 years, which is the best strategy to do this, and where to deploy this electric fleet, for example. So we can build this into the system. It's an optimization strategy that we have, which means that we minimize or maximize stuff, and stuff being mostly, for now, we are working on reducing costs, like mobilize the biomass throughout the entire supply chain network at least cost. But we could also, and we already do that, integrate more environmental criteria, like maximizing the reduction of CO2 emissions, for example, from the fleet, like greening the fleet, increasing the circularity, implementing more and more circular loops, and look at collaboration strategies with aligned value chains that are already existing, where you could tap into and tap out of, and to make use of those. And obviously also a collaboration of those or a competition of those via multi-objective optimization, where you can have conflicts between increasing the circularity vis-a-vis reducing the costs. These can be competing objectives. We work out together with the client scenarios. This is just an illustration, but differences can be like the centralization here of storage, while in this scenario the storage is more decentralized, while here the storage is the downstream processing is centralized, and this is lesser the case here. So we can build up variations together with the client, together with their interest, also influenced with the build-up expertise that we have to make the supply chain design as performant as possible. And then we analyze these scenarios one versus the other on the different factors that we have on economic impact, costs, environmental impact, CO2 emissions, social impact, for example, job creation. We also calculate, obviously, you know, the miles per ton transported, the loading rates, the vehicle movements that are required, etc., etc. Also, these KPIs we are free to develop them together with the client, and we bring this as decision support. We assess all the scenarios with the information and the requirements of the client, and we bring this back via reporting, explaining why scenarios differ from one to the other on different KPIs, and also bring this forward as decision support, which is still kind of theoretical. So in my last slide, I bring forward some cases we built up in the last years. These are just like inspirational, hopefully also inspiring, not limited to all the things that we bring forward. But to start, this is on roadside grass. In this project, the idea was to refine this grass towards fibers. And this is a case in Flanders, Belgium, where we had all roadsides in Belgium and the grass produced there. We had all the storage facilities, which are colored here by the red dots. We had the existing composting installations, and we had envisioned new material applications. And in this depicted figure, you can see like one of the mobilization strategies, this time using all the available resources, also using all the storage facilities to its best capacity, minimizing costs, allowing existing composting installations to still get served with the right amount of feedstock, while allowing opening of different material applications, which in this case related to also different quality requirements, going to insulation, as well as recycled paper, as well as composite. So it gets quite complex quite quickly, and that's why we have our optimization model to services. And next one is in Greece and is on peaches and nectarines. This was for a cooperation of a few hundred of farmers who were bringing their fruit directly to the cooperation, which required a lot of additional time from their hands, as well as a lot of additional mileage. There we analyzed like what would be if it would be feasible, and it would, to arrange pickup routes with a cool truck that the corporation could buy, and then they could be focused more on their core activities. We also put this in a dashboard, allowing the corporation to have a logistic planning tool and to also better plan ahead to get enough, let's say, peaches and nectarines in view of the orders they needed to fulfill in the upcoming weeks. This next one is Andalusia, Spain, which you see depicted here on the map. Here it regarded prunings from olive trees, on which they have a lot. It's a hotspot, as we know, in the world of olive production. So there are a lot of branches coming off, and here the interest was on using these woody resources as a precursor for bioplastic production. Here we did an assessment using the existing olive storage capacities and processing installations on what would be the best mobilization strategy to mobilize these woody products from field to storage, to pre-processing and drying installations, and to final processing in biorefineries. We also played around with different capacities and number of installations in the region, also put up a pathway of development from in time, kind of speak. Here, this is depicting just the information that you could get, like it's also broken down costs per cost element throughout the supply chain, indicating changes from one scenario versus another scenario. And finally, this is in the marine world. It's on marine algae production in Scandinavia. where the ambition was to use these algae to dry, powder them, and to be used as additive for feed application in Europe. And there we analyzed how to bring this material, which deteriorates very fast, from sea to harbor, and from harbor to drying installation, and from there to final applicants. There we again did a drill down of the costs. As well, here is an indication of sensitivity analysis where we looked at the impact if the anticipated production of these algae per square mile would increase at sea, as well as what would happen if more or less harbors would be open to receive these products. So this is just like a plateau of options that we have. Just as an inspiration, we're open to discuss any other supply chain design or optimization questions you would have, and that's the technical assistance service we provide in ToBeReaL. And I thank you on behalf of myself and Annelies, as well as our colleagues who are listening in, Lawrence and Jill, on behalf of the MOVE team. Thank you.
Thanks a lot, Ruben. Very insightful indeed. Myself as well. So we are going to continue then with Jasmine Versick, who is the business developer for bioeconomics at B2B. And she has a lot of experience from the management of Lyric Business School and Karl Leuven. And I already can see your full mode presentation on the screen. The floor is yours, Jasmine.
Okay, thank you, Tanya, for the introduction, and welcome everyone also from my side and from B2B, or also ILVO's side. I will be telling you a little bit more of the piloting infrastructure that ILVO has to offer through the services of ToBeReaL for your interest. So ILVO is a research institute in Flanders focused on agriculture, fisheries and food. We are partly funded by the Flemish government, but our biggest activities are funded by our own activities and generations. And our mission is to make agriculture, fisheries and agri-food sectors more sustainable. We do this through independent scientific and applied research, and our research is divided over 4 research units: our plant sciences research, animal sciences research, technology and food, and also social sciences. For our research, we also focus it on 10 themes, going from food and health to the role of animal production in society, to resilient food systems, agriculture and the countryside, bioeconomy and closing loops, precision agriculture, marine production, climate smart food production, protein diversification, and also, of course, healthy soils and crops. Now, to do our research, we of course need infrastructure. We have 10 sites in Flanders, close to Ghent, and also in Ostend by the sea. We have 220 hectares of trial fields and 50 hectares of organic trial fields. We have experimental greenhouses and also animal housing. We have 40 specialized labs, and we also have, of course, specialized research facilities. And for the remainder of my presentation, I will focus on the fact that we also have pilot plants for food, feed, and the post-harvest. First up, I'll start with our food pilot. This is our longest existing pilot facility, and here we do everything and anything that has to do with testing and analyzing new recipes, new products, improving processing approaches for those food products. We can scale up to a semi-industrial production scale, and we do this by using latest technologies and also latest food processing machines. We also have food labs and nutritionists, and on the right you can see that some of our data. So each year we do more than 550 tests, to 20,000 nutritional analysis. We do this for more than 400 companies, and we do 100 recommendations. When it comes to the infrastructure of the food pilot, you can see on the left the types of products that we can make or work on. So, for example, dairy, meat, fish, fruits and vegetables, but also drinks, sauces, also feeds, and bakery chocolate products as well. We can do this on all food types, going from 0.5 kilo to 350 kilograms. And on the right, you can see some indications of the technologies that we can offer. But in general, I want to mention that we can offer you food processing experience, food authenticity tests, nutritional analysis. We can test flavor, odor, texture, and rheology. We can also look at the composition and microbiology of the food. We can do residue screening and detection, and we can also detect allergen and GMOs. And of course, all this comes with a lot of data technology. To give you some examples of our success stories and companies that we've worked on so far, this can go to, from example, Inex to Beneo, Empro, and so on. So it's really a broad range of SMEs to big corporates. Next up is our feed pilot. And as you can see from the image, this building is actually currently being constructed. But no worry, we already have some of the machinery that will be installed in this new building. So we can already offer you some of the services that I will mention, but they will only become more extensive when the construction is done. So our feed pilot is being created to produce precision feed, not only for our own experiments, but also, of course, for external third parties. This can cover feed for poultry, pigs, and cattle. And next to this, the feed pilot will also be a training center for operators, and it will also allow us to do technological experiments. Now, who are the third parties that can use our feed pilot services? Well, for example, food companies that have side streams, like, for example, potato processing sector and those side streams, but also companies with side streams from the chemical processing, like, for example, the bioethanol production. Also premixing companies, feed companies, and companies with feed technologies. And some of the questions, or the typical questions that we have gotten in the past, and that also led us to creating this feed pilot, is, for example, what are some specific components that I can maybe include in my feed? Is there a specific concentration that I can read of this component? What is the stability of my components if I mix them in a certain way? What is my pellet quality? And can I get the same feed quality if I use less energy? Here you can see how the feed pilots will be set up and what machinery will be in there. On the left side, so the lower side of the building, there will be tilting mixers, long conditioning mixers, expanders, presses, and counterflow coolers. On the right side of the building, which is the tallest side, there will be, of course, storage silos that we can store all different types of components for the feed. Also homogenation silos, again, tilting mixers, some mills and rollers, presses, and more coolers. This brings me to our third pilots, the post-harvesting pilots, and like the name suggests, this pilot offers services for the treatment needed after harvesting your crops and before the raw material can actually be processed further. This pilot can be used not only by farmers and SMEs, but of course also the broader industry, and you can use our services directly, but it can also be done through research projects. This facility is also set up in a way that food and non-food applications can be tested. Now, what can be processed? It goes from food, feed, seeds, and other types of biomass. Those products or biomass can be biologically cultivated, but also conventional way. Not all of the processing steps that I will cover are applicable for both, but most of them are. So we can do, for example, for the seeds, we can dry seeds after they are harvested. We can also optimize them by, for example, polishing them or dehulling seeds. But then also very importantly, we can clean or sort, for example, seeds. We can do this in 5 ways. We can sort by weight, size, color, shape, and in the future, we will also be able to do that spectrally. This is some of the machinery that we have. So like I said, cleaners, sorting units, those can be mobile or stationary, wind sorters, seed polishing, cameras for color sorting, seed brushing, and so on. So that were the 3 pilot facilities that I wanted to introduce you to, that you could consult through the ToBeReaL services. But ILVO, like I said, has 4 research units. By now, we almost have 800 researchers working at ILVO. So there's so much more that we have to offer next to these 3 pilot facilities. I'll give you some quick examples. For example, our Hydra's rainout shelters, where we can simulate droughts to test, for example, biostimulants. And we can also analyze the effect of a certain situation or droughts or product on the roots of the crops, so in the soil. Currently, there's also a new building that's being built, a new climate neutral and energy neutral poultry research stable. We also have our machinery departments with self-driving tractors and also drones. We have marine research, and then what I personally do with a B2B facilitator, where we have a matchmaker in the Flemish bioeconomy between farmers and the industry. So if you want to know more on how we can help and what our services are exactly, please don't hesitate to contact us through ToBeReaL and ask questions. Thank you.
Thanks a lot, Jasmine. Very demonstrative as well and very helpful for the ToBeReaL bio-innovators. We are actually now going to continue with a contribution from Jan. So Jan Zo is a project manager for Copilot at the Biobase Europilot plant. And he works for us since 1.5 years now. He's a coordinator of the Copilot project, and he will give us some insights on de-risking European asset. I think that is also of interest for many potential applicants within the ToBeReaL. It's the other one, Theodoli, sorry. We skip this due for time issues. Yeah, the second one, the black one. So that's Jan's contribution to this webinar.
Hello, everyone. My name is Yang Zhou. I am the project acquisition coordinator from Biobase Europe pilot plant. Pilot for You, powered by Copilots, is a unique platform for bioeconomy stakeholders, especially for bio-innovators to connect, collaborate, and innovate together with our pilot and demo infrastructures. Over the next few minutes, I will give you a very short introduction about Pilots for You, the platform of pilot facilities across Europe, and walk you through some activities and events maybe we have planned, and explain how you can benefit from joining our community. First, I'm guessing this picture rings a bell for most of you. It is a classic scale-up diagram. So the steep drop we call the valley of death. So on the blue line, the technological risk stays high, while we are still in the lab and only starts to fall once we hit the pilot scale. The yellow dashed line is the cash curve, or you call it the capital requirements. So the costs still low early on, then rockets upwards right when the risk is still scary. So that mismatch, the high risk plus the high costs, is why so many great ideas stall here. And it is exactly why shared pilot and demo infrastructures matter. So they spread the cost, shared expertise, and give bio-innovators a safe bridge across the valley. So how do you tap into these facilities? So here, where Pilots for You fits in. So on the left, you have got the technology readiness levels, TRL 1 to 4. That's the discovery phase, so proof of concept in the lab. Universities and research institutes are great at this stage. But once you reach to TRL 4 beyond, things get expensive very fast. That means you need kilos instead of milligrams. You need real reactors instead of flasks, and of course, engineers. So that green band, the TRL 4 to 7, is exactly what Pilots for You covers. So it is the bridge between the lab and the first commercial plant. And beyond TRL 7, you are into full-scale deployment and the business operations. So who is actually in this TRL 4 to 7 bridge? Across Europe, we now have more than 120 open access pilots and demo infrastructures. So you can see on the map, the darker the blue, the more sites each country hosts. So France and UK top the chart, but notice the spread from Portugal up to Finland and even over to the Baltics. So because all these pilot facilities are listed in one searchable database, Pilots for You, so you can zoom straight to the facilities you need, be bioinnovators in Belgium, or let's say downstream processing in Slovenia, without hunting for months. So we know where the facilities are. The next question is, what can they actually do for you? The Pilots for You covers 12 technology areas with more than 50 specific technologies. In other words, almost any step in a modern bio-based process is already running somewhere in our network. So for example, if you need to break down biomass, chipping, grinding, steam explosion, you will find it in the size reduction and thermal pressure area. Move a step further and you have pulping options, let's say chemical, mechanical, even hybrids. For high temperature paths, there are sites specializing in thermochemical conversion, like gasification and pyrolysis. If you're working with algae, no problem. We have got open ponds and photobioreactor facilities ready. Talking about the core bioprocessing is covered too, fermentation, aerobic digestion, enzymatic steps, all the way to tailored chemical conversions or material technologies such as fiber spinning. And of course, every process needs downstream separation and sterilization. So from membrane filtration to chromatography to UHT. Now, I would like to introduce the co-pilot, the consortium, which includes two pilot plants. One is us, BioBase Your Pilot Plants, as coordinator, and VTT from Finland. Also, we have multiple regional clusters to ensure that the bioinnovators can easily connect with our pilot plants and access the upscaling support we provide. So we start from mapping and reviving pilot facilities from the Pilots for You database. So I would say more than 80 pilot facilities we have interviewed, so assess their current capacities, operational challenges, and future needs, etc. We also engage more stakeholders, so not only pilot facilities, but also bioinnovators to co-create the future-proof Pilot for You, a platform tailored to user needs. So that means we will bring more features and provide a complete overview of all pilot facilities in the EU. And moreover, the new Pilots for You, the database, the platform is not a static database. There will be a lot of activities promoted on the platform and organized by the platform. For example, open day visits of our pilot facilities. These open day visits will not only showcase their facilities, but also provide specialized training sessions to help bioinnovators scale up their innovation. And of course, this open day visit will also enhance the visibility of our pilot and demo infrastructures and provide excellent opportunities to build new connections and generate potential commercial leads. And next, the brand new Pilots for You platform powered by co-pilots is designed to streamline the search for bioinnovators to find ideal pilot and demo infrastructures. So no more browsing through 10 different websites. Also, the event calendar offers stakeholders easy access to a very wide range of opportunities, including online and on-site events, training sessions, matchmaking activities, and more. Finally, I encourage you to follow our co-pilot LinkedIn page. By following our page, you will receive updates on upcoming events, webinars, and keep track of all the exciting things happening within the Pilots for You co-pilot network. And for more information or support, please feel free to get in touch. I'm looking forward to working with all of you and seeing your innovative ideas take shape through our initiatives. Thank you very much.
Thank you, Jan. That was great. So now we've been through all the presentations and contribution to this webinar, and we still have some time, so I would like to open the chat for Q&A. And in the chat, I could see we already received one question. The other one I received through the Q&A, so I don't think it's visible for you. But the first one is for Lara. So Lara, what did you actually mean by a flagship project?
Okay, so as I could read this question at the beginning, I was able to open this slide that I'm going to share with the audience. Because in fact, due to the lack of time, I didn't have enough space for give specific guidelines about what we are going to require for those bioeconomy projects to be able to apply to ToBeReaL services. As you can see, they are very, the ones that you have seen now from our partners, quite high level experts, and we are going to offer. Remember that this is a public European project for free, so very, very impressive, I must to say. So, but we have to stick to our requirements regarding what is a bioeconomy project, what is a flagship project, and this ToBeReaL project, following the European Commission strategy to boost regions, the widening countries. In this specific project, we also are going to pay attention to regions, countries where bioeconomy is underdeveloped. So we everything is in our website, in the guidelines, but answering to Grant Campbell, I'm going to show you the definition of flagship. So it's not the typical definition of a flagship project that you can find in the EU CBE program, where you have these flagship projects that they are big one. It's like a combination of that and beyond what the CBE program means with flagship. So flagship project aims horizontal and vertical integration of the value chain, and thus it integrates technological, commercial, legal, and social feasibility systemically or horizontally, so that there is a long-term potential growth of this project. So this is very important that all these verticals are within your vision. Of course, serves to strengthen bioeconomy sector in Europe to generate sustainable model solutions, business model solutions, very important for economy, but also for challenging, facing the challenges of the society. It's a flagship project because it's a specific and high-level importance. It creates awareness of the problem among the general public, so really fulfilling society and public needs. It has a national and international visibility for the country. Is set up the flagship project, and important is that we have to see that there is a vision towards the funding of this project, either if you are a public project, so that you have considered perhaps to apply of a CBE flagship topic in Horizon Europe, or that you have already pay attention to the possibilities of private funding, and within the 2 to 5 years vision. So that's something for us to be important to check.
Yeah, thanks for the comprehensive answer, Lara. I hope it's clear, but otherwise we are all here to answer more questions. In the Q&A, actually, I received another question from Muriel, and somebody was wondering how much time in advance do I need to get in touch with Biobase Europe pilot plant to have a process running, or also to use the TEA or the engineering services?
Thanks for the question. A typical time is the preparation time we need to perform a project, to source the raw materials, to get all the details in place and the contract in place with the customer. And that is somewhere around 2 months or 3 months.
Yeah, that's a good, quick answer. I had received a question for Fernanda as well, like which kind of input is actually needed to perform such a TA that she presented. Because some or most of the bio-innovators that are approaching us are at lab scale, so somebody was not sure if lab scale data basically was sufficient. So I will answer that for her. Well, usually lab scale data and experience is sufficient for a preliminary TA that we're going to perform also in the ToBeReaL project. But then later on, the information needs to be translated, of course, into the process design and the simulation and industrial scale. At lab scale, there are many assumptions that are going to be done, that are going to be needed. And later on, if the project is at pre-industrial or industrial scale, there could be some significant changes in the process condition, for example, occur, or the equipment itself. But for first preliminary TA studies, lab scale data are totally enough to approach us to apply the service. Okay, and also there was a question for Janko, how much time in advance should be foreseen, also for the engineering services. It's a little bit longer, it's around 3 to 4 months. That needs to be taken into consideration for the basic engineering and feasibility study. But yeah, indeed, we basically try to order or check the long-term considerations and items up front, so these can be already ordered, so nobody's basically losing time looking at the holistic picture, the bird's view, and then going into detail for the functional descriptions. So basically in half a year it should be feasible to perform such a study and have the equipment and unit items also delivered. Okay. What else? Yeah, I come to the question for Ruben in a minute, because there was also one for Ruth. So somebody wanted to know who's actually providing the services in your team that you presented. Maybe you can quickly
Yes. Is a quick answer. Yes, although our center is an innovation center, so almost all the personnel we have here are doing innovation. We have a specific innovation unit. We are more than 15 people now, and we are for different backgrounds, just covering all the 5 challenges I was describing before in my presentation. So in the first stage, we are the ones that are providing all the services, and of course, we will have the support of all the technical areas that are working at AINIA, just trying to give support and clarify something that we may need.
Yeah, great. That's very clear indeed. No, also in the chat there was a question for Ruben. So do you do the MOF services also in other countries, such as Southeast Asia, and maybe you can also say of all the locations that you're taking into account, do the locations of these activities need to be known beforehand?
Okay. Well, to come to the question, like, do we do this type of service in other countries as well? The short answer is yes. You know, the service is geographically indifferent. The personal answer would be like towards South Asia, yes, would be very fun to do and take this endeavor on. Having that said, we require some kind of input data as well on production and location. So there we would need to engage in collaboration with the local client to frame the right setting. But we're geographically, let's say, indifferent and can apply the service, you know, worldwide. To the question on do the locations need to be known? No, well, it depends. So basically we start mainly if there is an existing situation from the as is situation, do this as a base calculation, and then offset this towards alternative situations. Regarding locations, sometimes the client has candidate locations, like we have ID on 20 locations for a storage facility, but we don't know which is the best fit. So then we get a list of candidate locations. We can provide such candidate locations ourselves based on assessment and bringing together geographical data, or we can do a full greenfield analysis, you know, allowing virtually any place in the region to be the location at hand, offer this to the model and have the model selected the best location. So different variations are possible, but it's not required to already know the locations.
Yeah, very clear. Thanks, Ruben. So I'm just going through the different questions here along the presenter. So for Jasmine, you actually mentioned or you're working for the B2B facilitator, but you didn't explain much on this facility. Can you explain more what it is?
Yes, thanks, Tanya. So the B2B facilitator, like I said, it's a matchmaker in the Flemish bioeconomy. So we try to link farmers with the industry, and we do this in 4 big ways. And I'll quickly give some highlights on them. First, it's an individual way. So we get a lot of questions from farmers, but also from companies. So for example, a company that's producing a product that is at the moment fossil-based, and they want to make it more biologically based or bio-based, we can look for those local raw materials that they can test. Other way around, farmers that have a side product and they currently can't valorize it, we can look for companies that valorize it. So that's the first one. That's on a very individual basis. Second activity that we do with the B2B facilitator is we work thematically. So every year, approximately, we work on one specific topic to really bring those parties closer together. For example, we've worked on biocontrol, on dry and on wet side streams, on biomass hubs, on the specialty chemical sector. So a lot of topics that we've covered in the past. And then to quickly wrap up, we also work on communication to get bioeconomy more well known with our stakeholders, but also with the broad public. And we also monitor the bioeconomy in Flanders to see how much a certain sector and the bio-based share of that sector is growing, and also to see how much mainstreams, but also side streams are produced, imported, and exported in Flanders. So a lot of topics that we've touched on in the bioeconomy, a lot of network that we have, not only in Flanders, but also in Europe and our neighboring countries. So we're very happy to, offer our services of networker and matchmaker for the ToBeReaL services.
Okay, thanks, Jasmine. So now for Jan, or the co-pilot presentation, pilots for you, powered by co-pilot. The question was like, because it's a database that is presented now with a new view on the website, how can it be actually accessed and filled from pilot and demo infrastructure services, also from bioinnovators? And yeah, I can answer this for Jan. So the current situation is that it's a very structured stakeholder engagement approach that is happening now. And bioinnovators and PDIs need to set up an account, filling out the required information with a contact person and their technical capabilities. So this is also with the support of the co-pilot consortium. And then basically it's been gained to access or to publish over 120 open access PDIs facilities. So that's the process currently going on co-pilot. Okay, I think we're good with the time. I just would like to take 1 minute to thank all the speakers and for their great contribution. And I hope it was very clear that which kind of services ToBeReaL project is offering, and also to the audience to stay with us for these 2 hours. Very intense information were shared. And the last information I would like to share with you are that we will put this webinar online. It was recorded. So you can follow up on the individual presentations or all of it together. The services in the project are still open and running, so there's an open call at the moment, again, for the technical services that were presented today, for the businesses and financial services, for regulatory and legislative services, and also for social innovation services. More information are to be found on the website, together with a guide for applicants that really step by step will bring the bioinnovators closer to become an applicant for ToBeReaL. Thank you again, and I wish you a nice Friday and a nice afternoon.
Thank
weekend.
you all.
Thank you.
Thank you, everyone.
Bye.
Bye.